Hey guys, Justine here from Compass Tutoring. So in this video, we're going to explore the topic of discriminants and what it means for the parabolic function and how finding a discriminant can help you determine what kind of parabolic function it is, whether it's like a positive, definite, or whether it's indefinite, but also what it tells you about the x-intercepts on the curve. So before we get into the crux of discriminants, we're going to look at where it actually comes from. So I know most of you guys can recall this equation right here. So this is known as the quadratic formula, and this helps you determine the x-intercepts on your parabolic function. So the discriminant comes from this formula, and it only takes a part of the formula, and the part of the formula that it takes is the part that's under the square root. So it's this b squared minus 4ac. So the discriminant is b squared minus 4ac. So what do these letters represent? So if you do recall the general form of your parabola, so it's ax squared plus bx plus c equals 0. So a represents the coefficient of x squared, b is the coefficient of x, and c is the constant. So the discriminant comes from this. Now this formula helps you find the x-intercepts on your parabolic function. Before we get into the value of each discriminant, I just want to bring to light the different synonyms of an x-intercept. So a question could ask you to find the x-intercepts, or it could ask you to find the roots, or the zeros, or the solutions. So this is a really important concept for you to understand, the fact that x-intercepts also means roots, which also means zeros, which also means solutions. So these words all mean the same thing, which is pretty much find the x-intercepts of the parabola. The reason I want to bring this up is because questions can use any of these words, and students sometimes see these words and freak out, like, what are solutions? What does it mean by zeros? It just means x-intercepts. So all these words mean exactly the same thing. Okay, so now let's look at the values of the discriminant and how that can help us determine the roots or the x-intercepts of your parabola. So the first thing is if the discriminant is greater than 0, so if the discriminant is positive, then there are two unequal real roots. So what you mean by unequal is that they're different. So they basically have different values. So x equals 4 and x equals 7. So those are two unequal real roots. Then if your discriminant is equal to 0, then you have two equal real roots or one real root. So what that means is you can have x equals 2 and x equals 2. So you have two equal real roots, or you can look at it as just having one real root because it's the same number. And then finally, if the discriminant is negative, then you have no real roots. And the reason for this, if you think about it logically, if your discriminant is a negative number, then that means the number under the square root is negative. And we know that a negative square root, or a number under the square root being a negative, doesn't exist, which is why you don't have any real roots if your discriminant is negative. And then we have something called a definite function or an indefinite function. So a definite parabola or an indefinite parabola. So definite just means it has no zeros. So the discriminant is negative. And this can be broken up into two categories. So you can have a positive definite and a negative definite. So positive definite means that the coefficient of x squared, so a, is positive, whereas a negative definite means the coefficient of x squared is negative. As you can see, the discriminant in both of these cases is also negative because that is the definition of a definite. And then you have an indefinite parabola, and this just means it has at least one zero. So that means your discriminant is positive. So just really quickly, I'll show you what these look like. Okay, so let's consider a positive definite. So we know that it has no x-intercepts, and we know that a is positive, which means it could look something like this, or it could look something like this. So basically it exists above above the x-axis because it doesn't intercept the x-axis, and it's concave up because the coefficient of x squared is positive. And then you move on to a negative definite. So a negative definite could look something like this or something like this. So it still has it still has a y-intercept, but no x-intercept. And this one is concave down because it's got a negative, because the coefficient of x squared is negative. And then something like an indefinite could look anything like this, pretty much. So it's got 2 x-intercepts, or it's got 1 x-intercept. It doesn't matter too much. So those are different ways that your definite or indefinite parabolas can look like. Okay, so let's move on to some examples. So what does it mean when it says that your discriminant is equal to 7? So like we said previously, if your discriminant is greater than 0, then it means that we have 2 unequal or different real roots. So this means 2 unequal real roots. Then if your discriminant is something like -9, so -9 is less than 0, which means that you have no real roots because we can't have a negative under the square root. And then if your discriminant is equal to 0, this means that you either have 2 of the same roots or you have one root. So I'm just going to write it as 1 real root. Okay, so now let's look at how to find the discriminant when you're given your function. So we know that the discriminant is equal to b squared minus 4ac. So b is the coefficient of x. So coefficient of x is -4. So b is -4, and that's all squared. Minus 4. Just continuing on with the formula, minus 4 times a, which is the coefficient of x squared, which is 1, times c, which is the constant, which is 3. So this becomes 16 minus 12, which is 4. So the discriminant of this function is 4, which means that you have 2 unequal real roots. Okay, now let's look at how knowing the value of the discriminant can help you find different variables within your function. So here we have y equals x squared plus 10x plus g. So our constant is concealed by this variable of g, so we need to find g. And the way that we find g is with this piece of information here, which states that the discriminant of this function is equal to 0. So the first thing that we need to do is find the discriminant. So the discriminant is equal to b squared minus 4ac. B is the coefficient of x, which is 10, so it's 10 squared, minus 4 lots of a, which is 1, and c, which is g, we don't know c. Just simplifying this, you get 100 minus 4g. So how are we going to find g? Well, we know that the discriminant is equal to 0. So since this is our discriminant, we can equate it to 0. So we get 100 minus 4g equals 0. And now we simply make g the subject and we can find the value of g. So I'm going to subtract 100 from both sides. So I get minus 4g equals negative 100. And then divide both sides by negative 4. I get g equals 25. And there we go. Using the discriminant, we can now work backwards to find the constant within our parabolic function. So we can rewrite this function as y equals x squared plus 10x plus 25, now that we know the value of g. Okay, let's look at one more example. So this example is a little bit more advanced, but I just want you to remember the basic concept of discriminant. So we know when it's greater than 0, we have 2 roots. When it's equal to 0, we have 1 root. When it's less than 0, we have no roots. Okay, So it says, by substituting the line into the curve, so this is the line and this is the curve, show that they intersect when this equals 0. So this is just finding intersection points. So to find intersection points, we equate the curves. So I'm going to equate these two curves. So I get x plus b equals 2x squared minus 7x plus 4. Now I'm going to bring all these things over to this side to equate it to 0. So I get 2x squared minus 7x plus 4 minus x minus b equals 0. And now just collecting like terms. So 2x squared, we have minus 7x minus x becomes minus 8x. And then we just have plus 4 minus b equals 0. So let's have a look at this. So this is A, this is B, and this is C. Okay. So we just showed the first part over here. So next it says, by solving the discriminant is equal to 0, find the value of B for which the line is a tangent to the curve. So by solving that the discriminant is equal to 0, so it gives you a hint, find the value of B if the line is tangent to the curve. So the reason the discriminant is equal to 0 is because of this reason over here. If the line is tangent to the curve, it means that there is only one point of intersection. The reason is because of this. The definition of a tangent, so if we just consider any parabola and a point on the parabola, and we look at the tangent, the definition of a tangent is only one point of intersection with the curve that it is a tangent to. That's what a tangent is. That's why we know that when we equate these, when we solve these simultaneously, the discriminant is equal to 0. Because the discriminant equal to 0, if you recall from the previous few slides, we know that there is only one root, one real root, which is the same thing as saying one intersection point, which is the same thing as saying tangent. So these all mean the same thing. So it's important for you to understand the relationship between these two ideas. So with that in mind, once we know that the discriminant of this function here is equal to 0, we can solve for the value of b. So discriminant equals b squared minus 4ac. So b, we said, is the coefficient of x, which is -8. A is the coefficient of x squared, which is 2, and c is the constant, which is 4 minus b. We're just going to expand this, so -8 squared is 64. -4 times 2 is -8, and we're going to expand it with 4 minus b in the next line. So we get 64. Minus 8 times 4 is -32. Minus 8 times -b is positive 8b. 64 minus 32 is 32 plus 8b. Now, because we know that there is only one point of intersection, we can equate this discriminant to 0. So discriminant equals 0. Discriminant is 32 minus 8b equals 0. Now we just solve for b. So I'm going to subtract 32 from both sides. I get 8b equals -32. Divide both sides by 8. I get b equals -4. So now we just found the value of b. So if you go back to here, it says find the value of b for which the line is a tangent to the curve, and that's exactly what we did. We found the value of b. So that concludes this lesson on discriminants. So I really hope you understand the derivation of the discriminant, and also how it can help you understand the roots of equations. but also when you're given things such as tangents to curves and how that can help you understand the intersection points between those two functions. For example, like in the last example that we explored, one curve was tangent, or the line was tangent to the curve, which in other words means there is one real root between those two functions. So once we solve them simultaneously, we can equate the discriminant to 0 and then determine things from there. So that concludes this lesson. I really hope that helped.